Greetings, grade 9s. Welcome to this Worksheet Cloud grade 9 maths lesson where we take a look at factorizing the difference of two squares. I'm Mr. T, your math teacher for today. This is take 2 for me. The first time I recorded this video, I did the whole thing, and then when I had a look, it hadn't recorded my voice. So it was just video of me speaking, but you couldn't hear me. So let's hope it goes better this time. At Worksheet Cloud, we're all about having fun while we learn, and that is why we have put in place the Rewards Hub, where you can earn cool rewards while you learn, such as merchandise from Worksheet Cloud, like this cap. Hot chocolate from Nomu. Thanks very much, Nomu. Don't mind if I do. Sweeten up those study breaks. And yes, good boy. Sorry, I was just saying hello to my dog. I don't have the PlayStation 5 with me. I think if they'd given it to me to put in front of the video, you probably wouldn't have it as a prize. I wouldn't be giving it back. Okay, but enough about that. Let's get on with the maths today. Okay, factorizing when we have the difference of two squares. My goal today is really straightforward and simple. I would like you to be able to recognize when it's the difference of two squares that we're going to use for factorizing purposes and be able to do it. So there's certain clues that I'll mention during the lesson. Things to look out for that indicate that it's probably going to be the difference of two squares. So first of all, what is the difference of two squares and how do we spot it? It's craftily disguised. They're two terms and both of them must be squares. And it must be minus because it's the difference. So we're looking for two terms, one minus the other, and both have to be squared. I don't think we can get more straightforward than that. It says it all in the name. Right, okay, so here's what it says. If we have two terms like this, a squared and b squared, and we have a subtraction in the middle, then the answer is going to be two brackets, one a plus, one a minus. The first term is going to be the square root of the first one, so both of those are the square root of a squared, and the second term is going to be the square root of the second one. All right, obviously this is the very simplest format. We can get a little bit more complicated than this, but it's pretty straightforward. If you are of a mind, you may go the first bracket minus and the second bracket plus. It will work out to the same answer because multiplication is commutable. So whichever of these brackets you put first, it's still going to give you the same answer. I'm just biased towards plus. You could say I'm more positive about plus and slightly negatively disposed towards minus. Oh, sorry, teacher joke. Okay, so how does it work? Let's have a look at this, and we're going to multiply this out and basically do the reverse to see why it's true that we can do what I showed you on the previous slide. So if I'm going to do this, I'm going to go a times a is a squared, b times a is ab. In fact, let me put it on. So a times a is a squared. B times a is ab because we put it in alphabetical. A times negative b is negative ab. And finally, positive b times negative b is negative b squared. Now you'll notice, or I hope you notice, that the middle two squares, or middle two terms, cancel each other out. So plus ab minus ab is no ab. So we're left with just a squared minus b squared. And this is true for any expression where we have two squares. Okay, and with that, we may as well head over to the whiteboard so we can look at some examples and work through them. It's the examples that help us. So at any point while I'm going, if you're going, yeah, I got it now, then you can pause the video, see if you can do them on your own, and if you get stuck, start the video again, and if you don't get stuck, wait till I finish, play the video and see that you got everything right. Okay, so first up, I need to check if it's the difference of two squares, and you will have teachers that will give you a bunch of these and then throw in one with a plus, and you're going to try and do it as a difference of two squares, and it doesn't work. It only works with negative. So big clue when it comes to this, we've got two terms and there's a minus in between. Now you typically will be given these as part of a factorizing exercise that includes taking out common factors, which we practiced in the previous lesson, and factorizing trinomials, which we'll do in the next lesson. So those are different from this in that generally these have just two terms and it's the difference. But yeah, you're looking for squares, you're looking for difference. Let's see. A squared is a square, 16 is a square. So I can go right ahead and lay this out before I even start putting my answers in. Now I'm going to say, what is the square root of a squared? That's just a. So my first term for both will be a. What is the square root of 16? It's 4. So my second term in both brackets will be 4. That's it. That's the answer. All right, so it's straightforward like that. I won't say it's easy, because when somebody says something is easy, what they're really saying is, I find that easy. I mean, there's that saying, it's as easy as pie. And I'm going, if somebody asks me to bake a pie, I'll be in a bit of a panic. I'll have to search for a recipe, get all my ingredients out before I even start. I'm not brilliant in the kitchen. Okay. Actually wanted to share this with you. Today I was sitting in the staff room and I with my colleagues at lunchtime talking about various things. And I happened to have my iPad with me, and I opened it up, and it was still open on the page, on my whiteboard page, showing the algebra from factorizing or taking out common factors. And the one teacher looked at it and she's like, she said she feels panicky when she sees something like that. And I hope none of you feel that way, but if you do, know that you're in good company, because there are still plenty of adults who feel that way about algebra. So I'm really hoping that these lessons will help you feel more comfortable with algebra and demystify it and make it not something that you're terrified of. Okay, back to the maths. All right, so I'm looking at these two terms. Now you'll notice that this time I've got coefficients in it. That's the whole number in front of the fraction. All right, I've got to check that this is a square and that this is a square, this is a square and this square. So these are both squared, so the whole thing is a square. If I had this, that is not a perfect square, because although that part is a square, that is not. And so we can't take the square root of 3. All right, so I've got difference. I've got two terms where they are perfect squares. So I'm going to have an answer that is in this format, 2 brackets, 1 plus, 1 minus. Square root of 4 is 2, square root of x squared is x, square root of 9 is 3, square root of y squared is y, 2x, 3y. Okay, number 3. That's a perfect square, that's a perfect square. It's minus. I'm going to have 2 brackets, 1 plus, 1 minus. Square root of 16 is 4. Square root of y to the power of 4 is y to the power of 2. So the first term for both will be the same. Square root of 81 is 9. So my second term for both will be 9. Right. Nope. Wrong. Move. Don't draw. Let's have a look at the next 3. Okay. A squared minus 4. That's a square. That's a square. Answer is going to be in this format. Square root of a squared is a. Square root of 4 is 2. Answer done. Number 5. Both squares. Square root of x squared is x. Square root of 36 is 6. So you can see that for this, you kind of do need to know your squares. Now, with squares, I think most of the time you'll be able to get away with squares up until 13 squared, 169. So you should know the first 13 squares. Occasionally it's bigger than that, but most of the time they stick to that range when they're looking at squares, or algebraic, which is just looking at the powers. Okay. Getting tired of green, so I'm going to switch over to purple. This is a square because I can see 9 can be square rooted, and so can y squared, and 100 is also a square number. Square root of 9, let's put in my format, plus minus. Don't get into the habit of doing that before you've checked that they are actually squares, but once you have, you can do that. So 3y, 10, 10. Okay, number 7, 7, 8, 9. Let's go all the way down to 10. So I picked 10 relatively straightforward ones, and after that we moved on to ones where you actually have to take out a common factor before you can find the difference of two squares, which also will form part of your education this year. Okay, 16 and 49 can both be square rooted, so can y squared. So I'm going to have something like that. 4y, square root of 49 is 7, and there's my answer. Let's change colors again. Let's try yellow. That's a square, that's a square, that's a square. Can be difference of two squares. So the main trick when it comes to these is actually just to recognize when it is the difference of two squares. If you didn't believe that these were squares, or you didn't know they were squares, you would first have to try and take out a common factor and waste valuable time because there isn't a common factor for both of those. All right, square root of 9 is 3. 3, square root of z squared is z, so 3z. Square root of 64 is 8. 8. 25 and 9x. 25 is a square, 9 is a square, x squared is an x. X squared is an x. X squared is a square. Format's going to be like this, so it doesn't matter whether if you've got a constant first or you've got a variable first, it will work just the same. Right, square root of 25 is 5. Square root of 9 is 3. So 3x, 3x. And our final one, 11 squared, and p is a square, so we have plus minus p and p. Right, the first half has been quite short, but do we even really need an excuse of a no more hot chocolate break to have some no more hot chocolate? I don't think so, so let's have a break now. Let's be honest, studying sucks. But here at Worksheet Cloud, we make it suck way less. In Worksheet Cloud, you can earn avatars, sidekicks, collectible coins, and then level up all while studying. Plus, we've just added our most exciting feature to date, the brand new Worksheet Cloud Rewards Hub. With Worksheet Cloud Rewards Hub, you can earn epic rewards and unlock entry tickets to win real giveaway prizes, including a Sony PlayStation 5, some yummy Nomu hot chocolate, and some fresh Worksheet Cloud merch. The more questions you answer, the more points you earn, and the more rewards you unlock. Worksheet Cloud makes your studying easier with video lessons, practice exams, practice questions, and study notes. In other words, we're your go-to place for all your studying. Ask your parents to sign you up at worksheetcloud.com today. You really should drink it before it gets cold, unless you're having a cold one. You know, it's the second time I've shot this video. I feel sorry for myself. My voice is getting hoarse. Just need to have one more sip. Okay, I'm ready now. All right, let's move across to these. These you can immediately see are a little bit more complicated, but I think with a little bit of careful work, we should find that it's not as complicated as it looks. Okay, so let's first of all take a look at these. Now, if I look at the bracket is squared, so the square root of that would then just be x minus y. So that part's a square. However, 3 is not a square and neither is 12. So if we've got two terms and we have a subtraction in the middle, then chances are good that it's going to be difference of two squares. Not always, but fairly good. So let's start off by taking out a common factor of 3. So what I'm going to have left then is x minus y all squared minus 4. I've used square brackets just to differentiate. Okay, and if I look over here, that's a squared and that's a squared. So inside my brackets, I have the difference of two squareds. So I've got 3. And then inside my bracket, I'm going to go x minus y. Oh, sorry, let's actually lay it out properly first. So bracket, 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 plus minus. And then let's close the square bracket. So square root of x minus 2 all squared is x minus 2. Now you can keep that in a bracket if you want to, although the bracket is not going to mean anything. Let me just zoom in a little bit over here. The bracket's not going to mean anything in this particular case. All right, and then our square root of 4 is 2, x minus y, and 2. Right, best practice is then to multiply out and see if we can simplify this. I'm going to now have to shrink it a little bit and just move it across. I'm going to do it on the right hand side over here. So I'm going to say equals, I've got my 3 on the outside of my bracket. The brackets on the inside don't make a difference, the smallest ones, but I've got x minus y plus 2 multiplied by x minus y minus 2. Right, and then we close our big brackets. Okay, and there's our final answer. Number 12, we've got a variety of variables in both, but if we take a closer look, you'll see that 2 and 8 are not square numbers. So we're probably going to have to take out a factor of 2. So let's see what else we can take out that's common. We've got 3 A's here and 1 there. The most we can take out is an A. We've got 1 B there and 3 over there. The most we can take out is a B. What we're left with in the first bracket is A squared minus 4B squared. And wonder of wonders, that's a square and that's a square. So 2AB, open bracket, 2 brackets will be inside, one will be a plus, one will be a minus, and we will get A and 2B, 2B. Done. Number 13. Now I'm glancing at 13, that's a square. That's a square because it's got the square of the whole bracket. That's a square and that's a square. So this one, we don't need to take out a common factor. We can go right ahead and factorize. Right, so let's make these brackets fairly big. Right, so that's going to be 3x minus 1, 3x minus 1. And the second part will be 4x plus 2. 4x plus 2. Right, there we go. That one's finished. Number 14. So, again, noticing that we have a squared part here. We've got a difference. We've got two terms. Looks likely that we'll have the difference of two squareds, but we don't know for sure. But it's definitely not in the format yet because we don't have 5 is not a square and neither is 45. So let's see if we can take out something as a common factor. My first gut feeling is that 5 goes into both of those. So let's take out a 5. So I'm left with x squared minus 9. Aha! X squared and 9 are both squareds. So we have 5 and then 2 brackets, plus and minus, x and x, 3 and 3. Familiarity. I hope it's becoming more straightforward as we go and you're going like, I know what's coming next. I know what's coming next. If you are, let's try these few. See how you go first. Okay, 15. 63 is not a square number, and neither is 7, but I do notice that 7 goes into 63. Let's see if we can take out a common factor of 7. Let's see what we're left with. Well, 7 goes into 63 9 times. And we're left with the next squared over there. Aha, yep, that looks good. Both squareds. 7, open bracket, close bracket, plus minus 3 and 3, x and x. And we move on to number 16. We are flying through these. Okay, now I'm going to do this one two ways. So my immediate thing is I noticed that that's a squared and that's a squared. That's squared, so we could do difference of two squareds. So we could say 6x squared, 6x squared, 3 and 3. But what I notice now is that there's still a common factor between those two and between those two. So although it's not wrong and we would then have to take out a common factor from there, you will find it much easier if you take out the common factor first. So let's see, 9 goes into both of those. Let's take out a 9 and see what happens. Right, so 9 goes into 36 4 times with x squared. Oh, I should probably, and then minus 1. Okay, and that's a squared and that's a squared. Don't forget that 1 is a squared. It's useful and it does pop up every now and again. Occasionally it is forgotten. Okay, so moving on the side, we've still got our 9 on the outside. Then we're going to have our two brackets, plus and minus, 2x and 2x, 1 and 1. And there we go, it's our answer. Okay, so just because I like people to understand that it's the same answer whichever way we went. If we'd gone the other way, which I'm going to do over here, we ended up with 6x squared plus 3, 6x squared minus 3. Okay, I'm doing something not very good. I'm going up instead of down. All right, so I'm going to take out 3 from there. So 3 at the front, that leaves me with 2x plus 1. And I'm going to take out a 3 from here as well. So times 3, 2x plus 1. If I then combine my two 3's, I get 9 times 2x plus 1. Sorry, I put a plus over here. It should be a minus. And 2x minus 1, which is what I got over there. And I think the way that's below in green is just a little bit easier than that mess up top. But it does work whichever way you go. It's just simpler if you first take out the common factor. So that's always my first stop before I do looking for difference of two squareds, or in fact, even before I look for trinomials, which we'll do in the next lesson. I always start by looking for common factors. Okay, looking at our next question, 48 and 27, big numbers. How would you guess what we're going to take out as a common factor? All right, well, we want to end up with squares. So I'm noticing 27, if I put 3 into there, it would be 9. So let's see if 3 works. Check your divisibility rule for 48. We sum the things. 4 plus 8 is 12. If 3 goes into 12, then 3 goes into 48, which it does. Whoopsie. Right, we'll just rub that out carefully. There we go. All right, so we're going to take out a 3. That leaves us with 16x. Oh, no. There's also an x in both of them. Take out 3x. We're left with 16x squared minus 9. There we go. 16x squared and 9 are both squared numbers, so we can then go to our next step, keeping 3x on the outside. We're going to have two brackets, 1 plus, 1 minus, 4x, 4x, and 3 and 3. That's our final answer. Okay, this one, number 18, is also of that sort where we've got a square because the whole bracket is squared. So we are then going to have the format like this. I'll make it quite big. We've got a plus and a minus. The square root of this is x minus 3, which I'm going to put in a bracket. X minus 3. And square root of 4 is 2. Square root of 4 is 2. Okay, now best practice says that we multiply out the brackets on the inside. In this particular case, they aren't doing anything. All right, so I'm simply going to erase them and then simplify what's inside the bracket. So I've got x minus 3 plus 2, which gives me x minus 1. And my second bracket is x minus 3 minus 2, which is x minus 5. Right, second last one. This has got lots of nonsense on it. Okay, I see 4 goes into both of the numbers, so let's start by taking out a 4. I've got 2 x's there and 4x, so the best I can do is x squared. I've got 4 y's and 2 y's, the best I can do is y squared. What's left on this side? Y squared. And on this side we've got 9x squared. So y squared and 9x squared are both square numbers. So we can go leaving our 4x squared, y squared on the outside. We will then have the two brackets, 1 plus, 1 minus. We'll have y and y, and 3x and 3x. Okay, our last one for today. I picked a big number just to make life miserable. 256 is 16 squared. I think at this, yeah. So if I'd been doing this and I'd come across this amongst some others, I'd go like, oh, that looks squared and that part looks squared. It's difference, and we've got two terms. It's probably going to be that, and then I'd play around with 256 until I could figure out what went into both of them. I mean, what went into there, what it was squared, which is 16. All right, but before that, I'm going to take out a common factor, and I'm going to take out a common factor of x to the power of 4, which means that we're left with 1 minus 256 x to the 8. That's a squared, that's a squared. Keep our x to the power of 4 on the outside. Oops, let's do our brackets before we start. It's plus and minus. 1 squared, well, square root of 1 is 1. Square root of 256 is 16 x to the 4 and 16 x to the power of 4. There we go. I have deliberately just done these on their own because it's mostly about recognition, and the more you see them all together, the more familiar they'll be. If you were learning them along with the trinomials and factorizing those, I think there's a chance they might have been less visible to you. So these are good to look out for. There will always be some in the factorizing tests. Often you have to take out the common factor first before you do. But yeah, there we go. All right, let's head back over to here and remind you that when you're done watching the video, you should click the link below in the description, which will download a worksheet from Worksheet Cloud, a free one where you can practice what it is we've been doing. Then if you want to do some more practice, which of course would be good, then you should get your parents to head on over to worksheetcloud.com and sign you up. And when you go to them and tell them, Mom, Dad, I want you to sign me up for worksheetcloud.com, go like this. There are so many good resources there, not just in maths, in all my subjects. It's an investment in my education and my future. You've got to do it. And you can maybe, if you want to mention the Rewards Hub, where you could win that cool merchandise or the hot chocolate or possibly even the PlayStation 5. But I think put the emphasis on the education side. And actually, that is what Worksheet Cloud is about. It was designed to be a place where you can better yourselves educationally. But cool rewards are also cool. Okay, I'll see you soon. Have a good evening. Cheers.